Chapter 3, Problem 16 reads, a telephoto lens consists of a combination of two thin lenses having focal lengths of 20 centimeters and -8 centimeters, respectively. The lenses are separated by a distance of 15 centimeters. Determine the focal length of the combination, distance from negative lens to film plane, and image size of a distant object, subtending an angle of 2 degrees at the camera. So the first step is to identify our variables. We're given the focal length of the first lens, which we'll call f1, to be equal to positive 20 centimeters. The focal length of the second lens, f2, is equal to -8 centimeters. The distance between the two lenses we'll call L, and that's equal to 15 centimeters. We now can form a relationship between these three variables and we're trying to find for. We're trying to find the focal length of a combination, which we'll just call F. We can use the lens formula to solve for S, which is given in the textbook to be 1 over F equals 1 over F1 plus 1 over F2 minus the distance between them, L, divided by F1 times F2. By substituting the given values, we can solve for F to be equal to 1 over 20 plus 1 over -8 minus 15 over 20 times -8. If you want, you can just plug all this into your calculator and then take the reciprocal to find F, and you should get the result 53.33 centimeters. This is the focal length of the combination of the two lenses. Now in the next step, we need to find the distance from the negative lens to the film for an object at infinity from the first lens. When the object is at infinity, the image produced by the first lens is at its focal point. Therefore, the image is formed at 20 centimeters from the first lens. But the distance between the two lenses is 15 centimeters. So the distance from this image to the second lens is 15 minus 20, which is equal to -5. This lens will act as an object distance to the second lens, so we'll let the image formed at a distance we'll call S2 prime, and the object distance which we'll call F2, which is equal to -5 centimeters. So again, using the thin lens equation, we can solve for S prime, S2 prime, by plugging in 1 over F2, which we know to be -5, is equal to 1 over S2 plus 1 over S2 prime. Now we know S2 is -8, and we know F2 is -5. So fill in those variables, and we will have 1 over -5 equals 1 over -8 plus 1 over S2 prime. Now if you subtract 1 over -8 from both sides and then take the reciprocal, we can find S2 prime to be equal to -8 times -5 divided by -5 minus -8. Simply solving for this, you'll get S2 prime is equal to 13.33 centimeters. This is the distance the film has to be from the lens that has the negative focal length. Now the last step in the problem gives us a subtending angle, which we'll call theta, to be equal to 2 degrees. Now what this looks like is, if we have a straight line here, we can form a right triangle. Here's our 2-degree angle, not drawn to scale clearly. But if the object is situated in a distance of infinity, then the image will be formed at the focal point. So we can call H prime the height of the image at this location. Now we know to solve for H prime, we can take the tangent of the angle and multiply it by the focal point, the focal length. Plugging in the values, tangent of 2 degrees times 53.33. Make sure when you solve this on your calculator that you have degrees selected rather than radians, otherwise you'll get a drastically different answer. Solving for H prime, the image height, we get 1.86 centimeters. And that's our solution.